All right, guys. I'm going to just use my, like I said, I'm gonna use my pen up here, so it might look a little clunky, but I just want to talk about word equations. Guys, word equations are really just a culmination of what we have done since the beginning of January. So instead of giving you the equation itself as already formulas, it's just giving it to you in words, and you're going to write the formula off of it. So I'm going to do just 2 of these with you. But first, we haven't needed to worry about our diatomic molecules a whole lot with word equations. Now those are going to come into play. So again, I wrote those at the top. Again, it spells out Brinkelhoff. That's a goofy word, but it's always going to have 2 if it's one of these 7 atoms. So bromine cannot exist by itself. It has to be Br2. Nitrogen, chlorine, all of these, they have to exist by themselves. But remember that they're named as their normal name. So it'll just say bromine or chlorine gas. Sometimes it'll say gas, sometimes it won't. Just depends. Okay? So just keep that in mind. That's going to come back into play in word equations. So we're going to want to look at that here. Let's do number 2 together. Okay? So let's do number 2, aluminum bromide. So if you don't already have your periodic table out, you're going to want to have that and your polyatomics out. So your polyatomic list is also going to come into play here, as is your periodic table. You're going to need to know charges of different atoms and things like that. Well, ions, I guess. So the majority of these things are ionically bonded, so you need to know charges. However, sometimes with word equations, you also have covalence. What does a covalent name have that an ionic name does not? Good, prefix. Guys, listen, if you see di or mono or tri, that tells you it's covalent. I don't have to worry about charges. It tells you in the name what it is. The majority of these are ionic. You have to know charges and you have to crisscross them. But if it uses prefixes, then just write down what it tells you, okay? So let's look at number 2. It says aluminum bromide plus chlorine yields aluminum chloride plus bromine. So we're going to write that as a balanced equation. So before we balance anything, we have to get the actual equation written down. So aluminum bromide. Okay, so first of all, I'm going to start right here for a second. So aluminum. What is the charge of aluminum? +3. How do you know? It's on the periodic table in group 3. It's a +3 charge. And it's connected to bromide. The fact that bromide ends in IDE, ide. It's just a single element. It's not a polyatomic. It doesn't end in ate or ite. So again, it's ide. I'm going to look at the periodic table. What's bromide's charge? -1. Whoops. Okay, -1. So you're going to have +3 and -1. So what we're going to do is we're going to crisscross these, right? We're going to just bring our charges down. So I'm going to write the equation up here. So I have, how many aluminum do I need here? Just 1. How many bromide do I need? 3. Good. I bring that down. So there's aluminum bromide. There is my very first compound. Okay, aluminum bromide. Now I also have chlorine. Chlorine is just Cl, right? It's by itself. And this is where those diatomics are going to come into play. Because look at chlorine. Is that part of that list that I have written at the top? Is it part of Brinkelhoff? Yes, it is. So it's not just chlorine. It's Cl2, which is chlorine, but it can't exist by itself. So you're going to need to know if it is one of those 7. It's going to be a 2 after it, not in front. Don't do it in front. It's Cl2. Okay, so there's aluminum bromide and chlorine. That's the first part. Okay, what does that yield? What's that mean? The arrow. Good. So now here's my arrow. I've got yielding, producing, creating, forming. All of those are synonyms. Okay, So now it says I have aluminum chloride. So the nice thing is that whatever I have on the left-hand side, I have to have on the right-hand side. So I should know the charges for the majority of these. So I'm going to do, I have aluminum chloride now. So look, I've got Al again, which we already said the charge was 3+, but now it's bonded to chlorine. Okay, is chlorine by itself now with aluminum? It's not by itself, it's with aluminum. So now I don't bring that 2 over because it's not by itself. Now it's with aluminum, so I have to look at its charge. What's chloride's charge? -1, good. How did you know that it's -1? It's in group 7, yep. So I am not going to bring that 2 over because no longer is it by itself. I'm going to take and I'm going to crisscross my charges here. So I need how many Al here? Just 1. How many Cl do I need? 3. Okay, again, notice I did not just bring the 2 over. The 2 is not needed when it's with aluminum. It was needed when it's by itself, but no longer is it by itself. Now it's with aluminum, so you have to look at aluminum's charge. So that's where AlCl3 came from. And now you have bromine off by itself. Is bromine part of a diatomic? Is it part of that Brinkelhoff list? Yep, so what do I need to add? Good. I need to add that too. Okay, so now this is called a skeleton equation. All of my things are down. I just need to balance it. Okay, so what we're going to do to balance it, put those coefficients in front. So let's look at, we have Al and Br and Cl, right? So I've got Al, I've got Br, and I've got Cl. So on the left-hand side, the reactant side, how many Als do I have? 1. How many Brs do I have? 3. And how many Cls do I have? 2. Whoops. All right, obviously same elements on the product side. So Al, Br, Cl. How many aluminum on the right-hand side? 1. How many Cls? 3. How many Brs? 2. So if you look at it, is it balanced? Nope. So we're going to balance it. So aluminums are fine. So let's just start with bromine. I've got a 2 and I have a 3. Nothing times 2 gives me 3. Nothing times 3 gives me 2. So what will 2 and 3 both go into evenly? 6. Yep. So let's start with this side. What can I put in front of here that will make this 6? Good. If I put a 3 here, 3 times 2 is 6. Okay. So now let's go to the bromine on this side. What do I have to put in front to make this bromine 6? A 2. So I balanced out my bromines. But what else did I also change? I changed Al. All right. So bromines are good. Now let's go back. We have Als to fix and we have chlorides to fix. Let's just do chloride here. So again, I have a 3 and a 2. Both are going to go into 6. Yep. So what can I put in front of this to make this Cl a 6? A 2. So that changes Cl to 6. What did I also change there? Al, yeah. So that actually helped me out because I needed 2 Als anyway. So now I have everything but chlorine is balanced. What do I put in front of this chlorine? The 3. So now that gives me 6. So is everything balanced now? Yes, that is a word equation. I took words, I made it formulas, and then once I had the formulas down, I am going to balance it. One thing I want to just caution you on, if you are doing this and you cannot for the life of you get it to balance, double check that your formulas are correct, because I'm going to guess if you can't get it to balance, it's because you made a mistake as far as the actual equation goes. Okay. All right. How did that one go? Pretty easy?
So these ones are going to be on the test or hard?
Balancing is,
Right,
but not, no. What type of reaction is this? Name that reaction. Single replacement. Good. I have a single thing. And again, remember your diatomics count as a single thing. And then I have a compound. So I have a single thing and a compound. And then this and this end up switching places. So single replacement. Good. All right. Let's do one that's a little bit more intense here. Let's do number 7. Let's do number 7. 7's got a lot going on here. So let's do 7 here. All right, so I'm going to leave those diatomics up there. Okay, potentially we're going to need those. So look at number 7. We have copper plus sulfuric acid yields copper 2 sulfate plus water plus sulfur dioxide. So there's a lot going on there. So let's just break it down one at a time. Copper, what's the formula or what's the symbol for copper? Cu. Is Cu a part of this list up here? Nope. So do I need to put a 2 here? Nope. I'm going to just leave it copper. Copper's allowed to be by itself. All right. And then I have sulfuric acid. So here's a good review for acids. Did the prefix hydro get used? No. So I know that because there's no hydro, this is a polyatomic. Okay. So let's break this down. What does every acid start with? Hydrogen. Good. So I'm going to do this down here. So I'm going to do hydrogen. What's hydrogen's charge? +1. It's in group 1. It's going to be a +1 charge. Now, because it did not say hydrosulfuric, if it said hydro, then I would just be looking at S, single element. But because there's no hydro used, I know this is a polyatomic. So if I look at my rules here, what polyatomic ending gives me ic acid? 8. Yeah, anything ending in 8 will be changed to ic acid. So the fact that this says sulfuric, really what polyatomic do you have here? Sulfate. Good. What is the formula for sulfate? Good. SO4. Where did you find that information? Yeah, on your sheet. You always will have that sheet to look off of. You don't have to memorize that. And what's the charge for sulfate? -2. Good. So with these, okay, you're going to crisscross charges just like with any other ionic bond. Acids are no different. Okay, so I'm going to crisscross them. So when I make sulfuric acid, I'm going to bring this 2 down. How many hydrogen do I need? 2. And I'm going to bring this 1 down. How many sulfate do I need? Just 1. So I have H2SO4. Okay? Yeah.
Wouldn't you just be able to bring it down, like how you said on the first one, where there's no copper in like the top, but there's hydrogen on the top?
Hydrogen only needs 2 and it's by itself. It's not by itself.
Okay.
So in this case, it needed 2 because it was with sulfate. But if it would have said like nitric acid, nitrite or nitrate is a -1 charge, and it would just had 1. So only when it's by itself do you give it that 2. That just happened to have 2 because what it was bonded to had a -2 charge.
So you only use the top when it's by itself?
You only use the top ones when they're by themselves. Yep. Yep. Okay, so I have copper plus sulfuric acid yields. That yields is my arrow. There's my arrow. And we have a couple things going on. We have copper 2 sulfate. All right. What does that 2 in copper 2 tell you? Charge. Good. It told you it's charge. Always positive, so it's +2. And then it's bonded to sulfate. Here again, we already know what sulfate is. We use it on the reactant side. So here's SO4. And what is SO4's charge? Good. So I have a +2 and I have a -2. So what do those do? Yeah, they just 1 of each. They cancel out. I'm good with just one copper, 1 sulfate. Good. There is copper 2 sulfate. Again, that 2 doesn't tell you how many. Clearly, there's not 2 copper. It just tells you its charge. All right. We also have water. What is water? Good. H2O. Now we have sulfur dioxide. What is sulfur dioxide? S. Dioxide. Good. O2. Guys, is sulfur dioxide ionic or covalent? It's covalent. How do you know it's covalent? It uses di. It has a prefix. If it has a prefix, then I don't have to worry about charges. It's telling me in the name. I have 1 sulfur, I have 2 oxygen, write that down. With covalent, there's no ions, there's no positive, negative. You don't worry about that. You just put down what it says in the name. 1 sulfur, 2 oxygen. Okay? So this is now my skeleton equation. All right? Now, this one, when I balance it, I can't, usually I say that if you balance, if you see polyatomics stay together, then you want to keep them together. However, this one's kind of a mess in that if you look at sulfur is actually in 2 separate compounds over here, as is oxygen in every single one. So in this case, I'm not going to keep SO4 together. I actually am going to try and separate S and O's. It'll make it a little bit easier. So what I'm going to do, again, I'm going to balance. So I'm going to write everything on the left-hand side down. And I am going to separate it this time simply because S's and O's are in multiple things. So I've got Cu, I have H, I have S, and I have O. So how many copper are on this side? 1. How many hydrogen? 2. How many sulfur? 1. And how many oxygen? 4. Good. And then on this side, how many copper? 1. How many sulfur? Plus the one over here gives me 2. So that one, I had sulfur here and here. So the one here plus the one here is where the 2 came from. How many O's do I have? Good. I have 4 here. Plus 1 here gives me 5. Plus 2 here gives me 7. And then how many H's do I have? 2. Okay. So I can look at this and see this is not balanced. Coppers and hydrogens are, sulfurs and oxygens are not. So I always save oxygen for the end. I just feel like oxygen's kind of a pain. And sometimes if you save it for the end, it'll kind of fix itself. So not always, but we'll try. So over here, I have 2 sulfur, but over here I only have 1. So let's just try. What could I put in front of, it has to go in front of the whole thing. I can't just single out sulfur here. So what can I put in front of here? If I put a 2, okay, that does change my sulfur to what? 2. But I also changed hydrogen. What did I change hydrogen to? 4. What else did I change? Oxygen. Now how many oxygen are there? 8. Okay. 2 times 2 is 4. 2 times 1 is 2. 2 times 4 is 8. So that's where all those numbers came from. All right. So now nothing is balanced over here. But if I did hydrogen right here, I have 4 over here. What can I put in front of this to make this a 2? I'm sorry, to make this a 4. What's 2 times 2? What else did I change here? Oxygen. So how many oxygen are here? 4 plus how many are here? Plus that gives me 6. Plus how many here? So what initially kind of looked like it might be kind of a pain, it actually ended up not being too bad. Is it all balanced? Yes. Word equations. You take what the words they are, you write their balanced formulas, okay? Pay attention to Brinkelhoff. If it says bromine or iodine or nitrogen, it's not, and it by itself, it has to be by itself. There's the key. It automatically gets those 2's. And then you balance it when everything is done. Okay? So, again, I'm going to tell you, if you're practicing this and you are having a hard time balancing it, I'm going to guess that it's because your formulas are not correct. Just take a quick look at those. Okay? Questions on word equations? All right.